Hey, this is Miss Silver Plata. I'm here again to continue with our Module 2 lessons. Here, we are going to look at Lesson 4, okay? Now, in Lesson 4, we're still going to divide fraction by a fraction with more models, okay, and more word problems. You want to be experts when it comes to fractions. All right, so let's start with a review of equivalent fractions, okay? Write at least 3 equivalent fractions. Be sure to show how the two fractions are related. Okay, so I have 2/3 and I have 10/12. So go ahead and try to recall what you know about equivalent fractions. Okay? So at least 3 equivalent fractions for each one of this. Okay? So I hear you say 2/3 can also be 4/6. That's correct. Okay? If you wrote 6/9, that's also equivalent to 2/3. And if you say 10/15, that is also equivalent to 2/3. Very good. All right. What about the next one? At least 3 equivalent fractions. Now this one is 10/12. All right. If you wrote 5/6, that's correct. It's equivalent to 10/12. If you say 15/18, yes, equivalent to 10/12. Let's say 20/24. So that is also equivalent. Now the question is, how did you know that all these fractions that we have listed on the screen is indeed equivalent fractions? All right. So you remembered to create equivalent fractions, you multiply the numerator and the denominator with the same number to create equivalent fractions. Okay? So what am I saying? If I have the same numerator and denominator, what does that equal to? It's equal to 1, right? So let's say I have 4/4. What is that equal to? Equal to 1. What about 10/10? Also equal to 1. So any number that has the same numerator and denominator is equal to 1. So that's why to create an equivalent fraction, we learned is to just multiply our fraction with the same number. Because that simply means that we are multiplying our fraction by 1. And what do we know about the number 1? Any number you multiply by 1 gives you the same number. That's right. So let's see 4/6. What did we multiply to 2 to get a 4? You are right. Times 2. So I'm going to do the same thing at the bottom. Times 2. 3 times 2 is 6. 2 times 2 is 4. So that's why 4/6 is the same or equivalent to 2/3. Okay. What about this part right here? What happened? How did it get to 10 or how did I get to 5? Okay, so if I'm doing it backwards, this is 5 times 2 will give me 10. And this is 6 times 2 will give me 12. So 10/12 is equivalent to 5/6. So that's just a review of equivalent fractions. Okay, because later on we will need equivalent fractions to solve some of this division problem. Okay? Let's begin with example 1. Okay, read along with me. Molly has 1 3/8 cups of strawberries. This can also be represented as 11/8. So the 1 3/8 is equivalent to 11/8. They're the same value, they're equivalent. She needs 3/8 cups of strawberries to make 1 batch of muffins. How many batches can Molly make? So this question is really asking me how many 3/8 are in 11/8. Okay, so if you remember our lesson from lesson 3. Okay, we use a model to do that. Okay, so let's use a model to support our answer here so that we will know how many batches can Molly make. So let's begin with 1 and 3/8. Okay, and what did we say? 1 and 3/8 is also the same as 11/8, correct? Okay, so 1 and 3/8, meaning to say there's one whole with eighths. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then on the other side we'll do the same thing. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we're going to shade 11 of them because we said 1 and 3/8 and 11/8 are equivalent fractions. So I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 8. So I am going to label. This is our 1 and 3/8. Okay, so this is a division problem. We are dividing 1 and 3/8, which we also know as 11/8, equivalent fraction. And we want to know how many 3/8 are in there. Okay, so what do? I get 3/8 each time. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, but not all 3 are shaded. So what happens to this? We learned this in the previous lesson. So we have, on the end, 2 out of 3. Okay, so what does that mean? How many 3/8 do you see? 1, 2, 3, and a part, which is 2/3. So 11/8 divided by 3/8 is 3 and 2/3. So answering that question, how many batches can Molly make? Molly can make 3 and 2/3 batches of muffins. All right. So you have your packet. Let's look at example 2 and 3. On example 2, okay, it says, imagine that Molly's friend Xavier also has 11/8 cups of strawberries. He needs 3/4 cups of strawberries to make a batch of tarts. Now, how many batches can he make? Now, remember in the previous example, let's go back to that slide. Here, Molly needed 3/8. Okay. Here, Molly's friend needed 3/4. Okay, so it's still division, but we have a different fraction to divide. Okay, so let us look at the problem using a model. Okay, so 11/8, that's where I am going to start with again. So 11/8, 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. So what do we need? We need 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is your 11/8. Okay. So what do we need? We need 3/4 each time. So let's get 3/4 each time. But wait a minute. 3/4 each time? 11/8, they are not the same denominator. You are right. That's the reason why we started with equivalent fractions. All right, so when we divide, we can divide with equivalent fractions or this with the same denominator. So if that is 3/4, this is 8, okay? This is 3/4. What can I do? Okay, instead of 3/4, I need to find an equivalent fraction of 3/4 that will give me 8. Makes sense, huh? So here we go. If this is 8, what do I do to 4 to get the 8? This is just getting the equivalent fraction multiplied by 2. So I'm going to do the same thing on the top, times 2. Now see, your 3/4 is now 6/8. So instead of taking 3 here, which just doesn't make sense because that's 3 out of 4, okay, we need 6/8 instead. So I'm going to count 1, 2, 3, 4, 5, 6. So this is one batch of 3/4, which is equivalent to 6/8. And then I need 1, 2, 3, 4, 5, 6 right there. Did I get all 6? No, I only got 5 out of 6. Okay, so if I write the division problem here, 11/8, the original, divided by 3/4 is the same as 11/8 divided by, you are correct, 6/8. How many 6/8 do I see? 1. Okay, and the last one is just a portion of the 6/8, which is 5, 6. So what does that mean? 11/8 divided by 3/4 is 1 and 5, 6. So we say, what's the name of the friend? Savior. Savior has enough to make 1 and 5, 6 batches of tart. Here you go. Okay. Example 3 is what I would like you to work on your own. Okay, let me grab that and go to the next page. And this is what you have for example 3. So go on ahead and do that on your own. Okay, if you want, you can pause this video and come back to me with your answer, or you can continue. We can continue to look at all the exercises and problems on this page, and then you can just come back later on. Okay, but this one on example 3, I think, yes, is 6/8 divided by 2/8. Now this is pretty easy because look, I can see it's the same denominator. I can see the numerators are compatible numbers, so very simple. 6/8 divided by 2/8. What you got? 3. Very good. Okay. Now, 3/4 divided by 2/3. So division, fraction by fraction, but they are different denominators. So we need to make equivalent fractions. Okay. What is the difference between this problem and the problems we completed in lesson 3? Okay. The fractions in this problem do not have common denominators, but the problems in lesson 3 did. Okay. So what do we have? 3/4 divided by 2/3. Okay. So what do? We need to make them equivalent fractions first. So let me begin with 3/4. I want a fraction that I can also create 2/3 with the same denominator. All right. So with the 4 and the 3 here, what common denominator can we use? All right. So it's just like skip counting, okay? 3, 6, 9, 12, 4, 8, 12, and then just pick one that is common to both, okay? And that would be the 12. Okay? So here we go. What did I do to 3 to get a 12? 3 times 4. So I'm going to do the same thing with the top number or the numerator. 2 times 4 is 8. So what does that mean? 2/3 is equivalent to 8/12. My 2/3 right here is now 8/12. Okay? What about 3/4? What do I do to 4 to get a 12? Times 3. Okay? So I'll do the same thing on the top number or the numerator. 3 times 3 is 9. So 3/4 and 9/12 equivalent fractions. My 3/4 is now 9/12. Now look closely. I renamed my fractions. Instead of saying 3/4 divided by 2/3, now I'm saying 9/12 divided by 8/12. They are the same. They are equivalent fraction. They are the same value. Okay? So this is now my division expression that I need to solve. Now using a model, okay, so that's 12s. 3 here, 3 here, so that's 6, 9, 12. So I have 9/12. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to label that 9/12. I want a group of 8/12. Okay. So 8/12, that's one group. I need another 8/12. But wait a minute, it's not all shaded. Okay. So I need 8 again, but I only have one of the 8. Okay. So if I go back to this expression, 9/12 divided by 8/12, there's one group and a remainder of 1/8. So that's 1 and 1/8. Okay. So if I go back to the original problem, 3/4 divided by 2/3 is actually 1 and 1/8. So what did we do? Right? We change both fraction into an equivalent fraction so that both of them will have the same denominator before we divide. Okay? Now, there are exercises here. A model should be included in your solution. That's what it says. So I'm going to help you with a couple of exercises here, but the rest of it you are on your own, okay? So that you can practice what we are trying to learn here, okay? Let's begin with 6/2 divided by 3/4. What did you notice? Exactly. They don't have the same denominator. So what do we do? All right, we change them into common denominator, okay? So I have 2 and 4ths. What would be the best denominator? You are correct, 4ths. So if you say 4ths, I can keep my 3/4 because the denominator is also 4. It's already 4. But my 6/2, I am going to change that where my denominator is 4. So ask yourself, what do you do to 2 to get a 4? Okay, to get a 4, you multiply that by 2. 2 times 2 is 4. So I'm going to do the same thing for 6. 6 times 2 is 12. All right. So look closely. My 6/2 is now 12/4. So if I'm looking at the equivalent fractions, where I renamed the original fraction, they are the same unit now, and 12 and 3 are compatible numbers. So all I like to do is divide the numerator. So 12 divided by 3 is, yes, 4. So what does that mean? 6/2 divided by 3/4 equals 4, right? So there are 4 more exercises that follows, okay? They are not the same denominators, so you need to find equivalent fractions, okay? And in some cases, if you want to use, well, in these exercises, it says a model should be included in your solution, okay? I know it's a lot of work, but you need to do it so that you can master this concept, okay? So there are 4 problems or exercises waiting for you. You can pause the video and come back with your answers, or you can continue and go back later on, okay? So that's it for lesson 4. In closing, when dividing fractions, is it possible to get a whole number quotient? Yes, it is possible. When the dividend is larger than the divisor, the quotient will be greater than 1, okay? Another thing to think about, when dividing fractions, is it possible to get an answer that is larger than the dividend? Yes, it is possible. For example, 1 divided by 1/4. Okay, so if you write that as a unit form, 1 would be 4/4. So 4/4 divided by 1/4 is 4. Okay, and then finally, when you're asked to divide 2 fractions with different denominators, what is one possible way to solve? Of course, you know. Yes, change it to equivalent, or rename it. Rename it to equivalent fractions, okay? And then you divide. All right, so you have a problem set that you can work on, and an exit ticket also for additional enrichment. And that is the end of lesson 4. So stay safe. I'll see you next time with another lesson from module 2. Bye.